All right, let's dive in. Today, we're cracking open the architectural blueprint for building modern, robust, and seriously reactive Android applications. If you've ever felt kind of overwhelmed by all the different patterns and libraries out there, you are in exactly the right place. We are going to lay out a clear, practical blueprint, so let's get started.
It's the question every single developer asks, right? You've got this great idea, but turning that concept into a clean, scalable app? Well, it can feel like you're trying to navigate a maze in the dark. Do you start with the UI? The data? How do you make sure it all just works together without becoming this tangled mess?
Well, this is your map. Seriously, think of this slide as the legend for our entire architectural blueprint. Every single pattern we're about to talk about has a very specific job, a super clear reason why it exists. From separating your UI to abstracting your data, this is the core toolkit for modern Android dev. And we're going to tackle this just like we're building a house. First, we're going to build the structural frame. Then, we'll get the power and plumbing running. After that, we'll make sure the whole thing is built on a rock-solid foundation. And finally, we'll step back and see how all these amazing pieces fit together.
Okay, let's get to it. We're starting with the absolute skeleton of our application, the structural frame. The whole point here, the big idea, is to separate our concerns. We want to make sure each part of the app has its own distinct job, which makes it so much easier to build, test, and maintain later on.
First up is MVVM. In our house analogy, think of this as the clean break between the outside of the house, what the user actually sees, and all the internal wiring and structure. The view model gets the data ready for the view, but here's the key. It has no idea how the view is going to display it. That separation is absolutely crucial for keeping your UI logic simple and your business logic clean.
Now this slide shows a really important idea, isolating what your app does. Think of a use case like defining the purpose of a single room in our house. The kitchen use case is all about cooking. The bedroom use case is for sleeping. Each one holds only the logic for that one specific task, and it's completely isolated from everything else. This makes your business rules incredibly easy to understand and, even better, to test. So where does all this data actually come from? Well, the rest of the app doesn't need to know, and honestly, it shouldn't care. And that is the absolute magic of the repository pattern. It's the central utility hub for our entire house. When a use case needs some data, it just asks the repository. It doesn't care if that data is coming from a server miles away, a local database, or some cache. The repository handles all that complexity, giving you one clean source of truth.
And there you have it. You've got MVVM for your UI separation, use cases for your business logic, and the repository for your data. Put them all together and they form the strong, dependable frame of our application. Each part has a clear job, which makes the whole system predictable and just easy to work with. Okay, now that our frame is up, it's time to install the power.
A house frame is great, but let's be honest, it's not very useful without electricity and plumbing, right? This next section is all about powering our application, managing the flow of data, and handling all that important background work as efficiently as possible.
In the past, getting data from some background process to your UI was a messy business. It was full of callbacks and complicated logic, what we're calling the old way. The modern reactive way, though, it completely changes the game. Instead of you manually passing data all over the place, we treat it like a continuous stream that our UI can just watch.
And the tool for that is Kotlin's Flow, specifically state flow when you're dealing with UI states. This is basically the electrical wiring of our app. The repository sends out a stream of data, and the UI is connected to that stream. Whenever new data flows down the wire, boom, the UI updates automatically. It's clean, it's efficient, and it's way less prone to errors.
But what about those big tasks, the things that absolutely have to happen no matter what, like uploading a file or syncing a bunch of data? For that, we bring in the heavy machinery, WorkManager. This isn't for quick little jobs. This is for guaranteed, deferrable background work where reliability is everything.
And the process is it's beautifully simple. You just tell WorkManager what you need done, you schedule the task. Then the Android system itself finds the best possible time to execute it, thinking about things like battery life and network connection. And once it's done, the result is delivered right back to your app. Even if the user restarts their phone halfway through, WorkManager makes sure the job gets finished. It's awesome.
So our house has a frame and it has power. But is it going to withstand a storm? This final section is all about the foundation, the principles that make our app resilient, robust, and totally ready for the unpredictable real world.
Because let's face it, things go wrong. Wi-Fi drops, cell signals are weak, And as our app grows from a little cottage into a giant skyscraper, just managing all the different components can become a nightmare. So how does our architecture handle all of this?
The first answer is to think offline first. This is a fundamental shift. Instead of your UI always depending on the network, it depends only on a local database. That's it. The repository's job is just to keep that database synced up with the network whenever it can. So for the user, the app just works, always. It's kind of like having a backup generator for your house. The lights stay on no matter what's happening outside.
The second answer is dependency inversion, made so much simpler with a tool like Hilt. As our app gets bigger, different parts need to use other parts. Manually connecting all of them is tedious and super fragile. Hilt just automates this for you. Think of it like using prefabricated standardized connectors to assemble our house. It makes building way faster, and swapping out a part, like changing the plumbing, becomes incredibly simple, and you don't have to tear down the walls to do it.
So, let's step back for a second and just look at what we've built. We've taken all these individual patterns and components, and we've assembled them into this cohesive, powerful, and modern application architecture.
We have a clean structural frame that gives us clarity, we have dynamic power systems for data flow and reliable work, and it's all built on top of a resilient foundation that can handle real-world chaos and complexity with ease. Each layer has a purpose, and together they create an app that's a pleasure to build and, more importantly, a joy for people to use.
Look, this isn't just theory. It's a practical blueprint for success. You now have the architectural guide to build high-quality, professional-grade Android applications. So the only question left is, what amazing thing are you going to build with it?